extrema on an interval. Our objective is to identify absolute and local maximum and minimum values of a function. Let's begin with the absolute, also known as global extrema. These are the extreme values, the maximum and minimum values. Let f be a function defined on an interval I. F has a maximum, which can be called the absolute or global maximum. But if these words are left off and it just says maximum, it implies the absolute or global maximum. At x equals c, if and only if f of c is greater than or equal to f of x for all x in the interval. Notice greater than or equal to. That y value is greater than or equal to all other y values in the interval. Notice that it is f of c that is the maximum value. That is the y value that is the maximum. Not the x value, not an ordered pair, it's the y value that is the maximum of f, and it is located at x equals c. The location of it is the x value. Similarly, f has a minimum, which can be described as absolute or global minimum, at x equals c, if and only if f of c, the y value at c, is less than or equal to all other y values, f of x, for all x in the interval I. So again, f of c is the minimum. That means the y value is the minimum of f and is located at the x value c. Now, this is different from, but related to, local or relative extrema. These are the local or relative extreme values. The word relative should make us think of relative to points near or close to the point that we're observing. The word local, when we think of local max or min, we think also of close or nearby. And we want to be able to see on either side. We want to be able to see on both sides. So we say, if there is an open interval containing c, on which f of c is greater than or equal to f of x, remember this meaning that there is a maximum, then f of c is called a local maximum of f. Or of course it could be called a relative maximum of f. Think of a little hill. We can see close on either side to that point and tell that there is a local maximum at this spot. Again, for local or relative extrema, we must see on both sides, which means these cannot occur at endpoints. Notice it says in both of these, if there is an open interval, if there is an open interval. Open intervals do not contain endpoints. No endpoints for local or relative extrema. Whereas the absolute or global extrema, these can occur at endpoints because this is just the highest and lowest values of the entire function. Global, think of all of it like a globe. Absolutely the highest and lowest values no matter where they are. That's different from local or relative, where we're looking for points relative on either side in a local place. If there is an open interval containing c on which f of c is less than or equal to f of x, so low y values that are less than other y values, then f of c is called a local minimum. We can see on either side, and it's like a little valley. Example, use the graph of y equals f of x to identify and locate all absolute and local extrema of the given function. Let's start with looking for maximums. So looking in my graph, I'm looking at the y values, looking at the y-axis. How high does this graph go? And I see that the highest it goes is up to this y value, which is at the y value 6. Now, there are two spots where the graph reaches this y value. One is here and one is here. It doesn't matter how many spots there are, the absolute highest value that the graph goes is the y value 6. So we would say that the absolute maximum is 6, that y value. Now we can also tell where it's located by saying its x values. It's located at x equals, so let's go out this way and we see that that's at -7 and at +1. So at x equals -7 and 1. How about the lowest y value? Let's see how low the graph goes. I see the lowest it goes is down to here. Now it happens to only get there at one place. Doesn't matter how many places it gets to, that's the lowest that the graph goes. So we will write that the absolute minimum, is that y value, which is at -7, and is located at x equals -1. That's the location, but the minimum value is -7. Now let's look for local maximum values. I'm looking for tops of hills. Where do I see some? I see a top of a hill here. I see a top of a hill here. I see a top of a hill here, but that's a hole, which means the function value doesn't exist there. And that's the only place I see a top of a hill. This is a high point, but I cannot see on either side. An endpoint cannot be the location of a local or relative maximum or minimum value. So there's only going to be two tops of hills where I'm going to list my local maximum values. This spot that I come to first is at the y value, is the y value 2. So I've got to list my local maximum values. My first one is 2. It's located at 1, 2, 3, 4, -4. So at x equals -4. And then I have another local maximum value. It's 6. It's located at x equals 1. Now notice it's also listed as an absolute maximum value. Doesn't matter if it's already an absolute maximum, because it's the top of a hill we can see on either side. It is also listed as a local maximum value. Now let's look for our local minimum values. So we're looking for bottoms of valleys, like that. I see there's one here, another one here, a third one here, and a fourth one here. Lots of little valleys. So I've got that local minimum is 0, located at the x value, -5. The next one I come to is the y value, -7, also an absolute minimum, but it doesn't matter because I can see on either side it's also listed as a local minimum. So -7, which again is at the x value, -1. This sharp point is still a function value, and I can see on either side, so that is a local minimum, -2, located at the x value, 2. And finally, at this spot, 1, 2, 3, 4, 5, that's the y value, -5, and it's located at the x value, 1, 2, 3, 4, 5. So again, notice that at an endpoint, there can only be an absolute max or min. In this case, this one is only the absolute max. Whereas at an internal point where we can see close on either side, it could be both. This one happens to be both the absolute and the local max. And down here, this happens to be both the absolute and local min. Now, let's talk about what we see at local maximum and minimum values. All of these little hills are either nice, smooth, curvy hills or a sharp point like this one. So how would we describe the derivative or the slope of the tangent line at each of these local maxes or mins? Now, when it's a nice, smooth curve, that slope is 0. When it's a sharp point, that slope does not exist. So let's think about that in relationship to derivatives, that if a function f has a local maximum or a local minimum at the number c, then either the derivative at c will equal 0 or the derivative at c does not exist. Thanks for watching.